Hello guys, my name is Hang Phiên Ng. I am a sophomore at Paragon International University of Cambodia. I am from Department of Civil Engineering, Faculty of Engineering. Today topic is relating to the engineering dynamic course, which is instructed by Mr. Minh Linh Lai. The exact topic is Lotte World Tower wind earthquake resistant property. To ease your comprehension, I would like to introduce the content first, such as Lotte Tower background and structural system, the building introduction to amazing structure and its use material property, substructure of it, superstructure, and structural safety system. So first, I will talk about the background and the structural system of it. Lotte Tower is known as the fifth highest building in the world. It is located in South Korea, in Seoul, South Korea. There are 126 stories, and it comprised of different complex office, including a residential area, a shopping center, mall, office, and a observation deck situated at the top of the superstructure. It height 555 meters over the ground. Lotte area is one of the most attractive tourist destination, given its fantastic architectural design, which represents the modern and developed civilization of South Korea. Despite the aesthetic of the building itself, one must also acknowledge how the skyscraper stands soundly and securely. This enormous superstructure is embedded on a solid and strong mass foundation, which sums the foundation rigidity to 172 mega Newton per millimeter. It's 3 times stronger than the world's tallest building, Burj Khalifa. The building also comes with an amazing structural design that holds the building tightly by installing reinforced concrete mega column and a massive reinforced core wall, which are covered by buttresses and outriggers. It also comes with various emergency features such as disaster prevention system. Lotte Tower started its construction in early 2011 and ended in late 2016. The skyscraper consists of 126 floors and 6 underground floors. It's standing on total area of 304,081 square meters. This skyscraper possesses amazing structural safety technology and strongly focus on natural disaster occurrence impact such as earthquake and wind load. Structurally, this building is tightly held by one gigantic reinforced concrete core wall, HRC mega column, 2 sets of buttresses and outrigger, along with a variety of faculty and design in the structure. It also comes with great water fire management system for possible emergency cases. This structure is built by the gathering of the professional engineers all around the world. Here is some property of the material that have been used in the structure. The main material are concrete and steel. The vertical supporting member, which are core wall and mega column, use concrete of strength 40 to 80 megapascal, whereas horizontal support member, which are beam and slab, use concrete of strength 30 megapascal. Polymeric fiber injection method was used in production of high-strength concrete to prevent the structure from heat explosion, which have 60 megapascal or above. Rebar that was used to reinforce the concrete has a yield strength of 400 megapascal, whereas a yield strength between 235 and 440 megapascal. High steel strength of 650 megapascal is used for the cover, which are belt trusses, steel column, and outriggers. The substructure of the building is the deep foundation technique along with concrete mat installing beneath the superstructure. A concrete mat of dimension 72 as width and 72 meter as length and 6.5 meter as height, constructed by pouring 80,000 tons of high-strength concrete. And there are 108 foundation piles are driven 30 meters into the bedrock. This structure is built to be able to carry enormous dead load and light load from the structure. The soil below the foundation has an allowance bearing capacity of 3,000 kilopascal. So the substructure of it is working on the lateral load resistance or wind, or we known as our topic is wind and earthquake load. This part I will talk about the two main structure of it, the belt trusses and the outrigger. The significant structural component of Lotte World Tower are its mega column, a gigantic core wall, belt trusses, and outrigger. The mega column and the core wall are considered to be the backbone of the structure as they carry water and electricity, or we known as MEP, and major elevators that have transport throughout the building. The 8 columns are spaced approximately 25 meters apart. The column and the wall together work as a vertical resistance, meaning they hold the total weight of the structure. And the very bottom part of the building, the mega column dimensions are 3.5 meter by 3.5 meter. But as the height increases, the dimension change to 2 meter by 2 meter on the 66 floors. The core wall thickness parameter vary from 2000 millimeter to 600 millimeter. This dimension change are due to the tapering shape of the structure, which means the building cross-sectional area decreases as it ascends in height. The purpose of constructing a tapering structure is to reduce the impact of wind load on the building. And the final discussion, engineering carry out the optimal condition for the building in which 2 sets of belt trusses along with 2 sets of outrigger were being final to install that would perform simultaneously well together that to resist the wind and earthquake load. The combination of belt thrust and outrigger assists the superstructure when it encounters enormous lateral loads such as earthquake load and wind load. By implementing this technology, Lotte World Tower is being recognized as a skyscraper that is about to resist an earthquake of magnitude 9 Richter and a heavy wind speed of 80 meters per second, equivalent to a typhoon. The building top shape is constructed by using the diagrid method. The cross-sectional area of the structure decreases tapering until the interior of building converge to each other. The steel frame at the top lantern of the building are meshed together then from which result in more resistance to lateral load such as earthquake and wind load. Moreover, this building also contains structural safety management technology.